The life of a main sequence star. Here we see a cluster of main sequence stars. These are the Pleiades. And the fact that they're a cluster means that they're all one distance away from us. So the stars that look brighter are in fact brighter than their neighbors, which also is going to tell us that they're more massive. And the mass ultimately is what's going to determine what happens to a main sequence star. Now, as we saw, what triggers the beginning of the main sequence stage is the start of hydrogen fusion. That is the key event that designates a main sequence star. So, by definition, a main sequence star is a star that generates energy via hydrogen fusion. Now, hydrogen fusion produces helium. So, once the hydrogen fusion begins, the core of our star is no longer pure hydrogen. It's going to become a mixture of the hydrogen that has not yet been used and the helium that has been produced. And of course, over time, that proportion is going to change. So, every time a hydrogen fusion process occurs, there's less hydrogen. And every time it occurs, there's more helium. So you're going to get less and less hydrogen, more and more helium in that core. When the helium runs out, when the hydrogen runs out, and the core is entirely helium, that's when the star dies. So how fast that occurs depends upon the mass. And that's because higher mass is hotter. And if it's hotter, it's going to use the fuel faster. So to give you an idea of lifespans, a high mass star can have a lifespan as short as 1,000,000 years, which astronomically speaking is pretty short period of time. I know it doesn't sound like a short period of time on a human scale, but astronomically that is a blink of the eye. Now our sun falls in the middle category because our sun has a mass of 1 solar mass, and so we're in this middle. And so you can see the range, 2.7 to 14 billion years. Our sun is about 10 billion years for our sun. And then the lowest mass stars are as much as 200 billion, billion with a B, years. That is longer than the universe has existed. Our universe is roughly 14 billion years. And so that means that our universe has not existed long enough for any low-mass star to die. So that's an intriguing thought. Every low-mass star that has ever been born is still alive today and will be for quite a long time. So for a main sequence star, even though this is 90% of its lifetime, is spent as a main sequence star, it doesn't go through any changes. So it's a very simple stage in the life cycle of a star. And it doesn't start getting interesting until it starts to die, which is the next stage.